Okay. So I guess let's just start. What got you interested in this topic of shale gas and methane emissions?
Well, I've worked on methane emissions off and on since I was a graduate student back in the 1970s. It's a part of my thesis, small part of my thesis, but I looked at some of the natural fluxes from wetlands. Very frustrating thing to do with the technology we had back then. But I have a long-term interest in methane emissions. I was on sabbatical leave in France in the spring of 2009, and when I came home, all of a sudden there were advertisements all over the place touting natural gas as a clean burning fuel, a low carbon footprint, good for the environment, good for global change. And I was a little skeptical, to be honest. I wasn't sure, but that didn't quite ring true based on what I knew about methane and about greenhouse gas emissions generally. So we started looking for the science basis behind those ads, and quite frankly, there was no science basis. You can search the literature, and as of 2009 or 2010, there's absolutely nothing in the published literature on what the greenhouse gas emissions from shale gas might be. So we decided to take it on as a research topic to see what it might be.
And what did you find?
Well, our conclusion is that the footprint isn't well known because the quality of the data that are available publicly are pretty marginal. But we used the best data we could find, the best data that are out there, and we concluded that shale gas has a very large greenhouse gas footprint compared to other fossil fuels even. It is technically clean burning. When you burn the fuel, you put out relatively little carbon dioxide compared to coal or oil to get a unit amount of energy. The problem is that natural gas is methane. It's overwhelmingly methane. And methane is an extremely potent greenhouse gas. So small leakages matter a huge amount in terms of the greenhouse gas footprint. We estimated those leakages from shale gas as being somewhere in the neighborhood of 3.6, maybe up to 7.9% of the lifetime production of a well. All you need to do is leak 1%. And you're equaling the carbon footprint of the carbon dioxide, the direct emissions, because methane is such a powerful greenhouse gas.
Right at the moment, I'm working on global sea level change, working on nanoparticles as tracers in the environment.
How did you get involved in this shale gas issue? What was the
Okay. Well, this came about because my colleague Bob Howarth and Tony Ingraffia and Renee Santorum were making a lot of talks, lecture presentations on campus, and then ultimately publishing their paper in climatic change. And as you can see, I consider myself, rightly or wrongly, a resource geologist, and I felt that their conclusions were just completely wrong. And I felt that it was important to say why. And so we published a commentary to their paper. They then published a response, and that's the end of the process as far as the journal is concerned. But we then electronically distributed a reply to their response.
What was your initial reaction when you read their first paper?
Well, initially it was hard to tell. I mean, they were making some assertions about leakage rates and the impact of methane compared to CO2, and in a oral presentation, it's hard to really see what is being done and what the basis for it is. When they released finally their paper, we had a careful look at it and found that they were using evidence. They used evidence of capture for evidence of leakage, and took pretty high extreme parameters and assumed a very high leakage rate. He says that the leakage from unconventional wells is something like 1.9% of total production, as opposed to 0.01%. And he increases the leakage from the pipelines from about 1.5% up to, I think, 4.5% or so.
We compare and contrast his numbers with ours and with many others. Our numbers are pretty similar to the EPA. They're a little bit lower than the numbers that the new NOAA study has come along with, which I think are the best numbers. There's a range of other papers out there. Professor Cathles' numbers are at the very, very low end, however. Doesn't mean they're wrong, but the very low end, and he provided no referencing or no documentation for where those came from. We have over 50 references and data sources for ours, so if he says it's the same, I mean, people should go and look at the papers. Well, the nice thing about science is at the end, it's not, I don't decide who believes Professor Cathles, and Professor Cathles doesn't decide who believes me. I'm pretty confident that our work will stand up to long-term scrutiny.